that correlate to what's here? Sound like a plan? You had a question over a homework problem, though.
Yeah, number 49 over 12.5.
12.5.
Yeah, the one that he assigned on. Okay.
49. X cubed over x squared plus 1.
Yes.
All right, so the instructions here, divide, use partial fractions. So we first do long division because the degree of the top is bigger than the bottom, right? So I'm going to set up a long division over here. X cubed, out here is x squared plus 1. And then we say, what do you multiply x squared by to get x cubed? X. Put that here, and then you multiply this through. So you get x cubed plus x. And then you come through and subtract, right? So when I subtract, I get negative x here, and the other one cancels, right? And then you ask yourself, what do you multiply x squared by to get negative x? And you can't. So this is your remainder, right? So you put up here plus the remainder over the divisor, like that. So what we're saying is that this is equivalent to this expression. And now I will try and do partial fraction decomposition on this, right? I thought I just had a towel up there. Oh, no?
There's a towel right over there.
I know, but I had one. It's hiding from me. Okay, so now what we do is we look at this as our whole problem. And the denominator is a quadratic that's irreducible, meaning it does not factor, right? So that means we're going to try and rewrite this as the quadratic with what on top?
Is that the
Ax plus b. Remember, it has to be linear on top, right?
Okay, that's what threw me off. I didn't know because previously we were doing like bx plus c, but
Oh, that's because we had used the a already.
right.
All right, but there's something really important here that you need to see. We're actually done with the problem at this point. Why?
Because there's no
Hey, come on in. Yeah, what is the numerator of the other side right now? Of the left side?
negative
Negative x,
x,
negative 1 x plus 0. Isn't the left side already a linear on top of the quadratic?
yes.
So why would we want to turn it into a linear over quadratic if it already is a linear over quadratic? Do you see what I'm saying? Our goal is to try and figure out if there's some number in front of x plus some number by itself over this, right?
And then
I actually already have that.
okay. That's what threw me. I was looking at the answer in the book.
Is this the answer in the book?
Something similar.
Yeah.
But it was throwing me, and I was like, "Where? That doesn't make sense."
12.5. 12.5. Yeah, that is. They put the negative out here, though. They slide the negative out here.
Yeah.
But that's
It's the same thing.
same thing. Now that will come up in a calculus class, and you don't want to be doing partial fraction decomposition to try and turn something into something that it already is, right? So we're done.
It's the long division, and then
That's it. For that problem, it was just the long division. Any other questions? You're welcome. No others?
That I can't figure out. Well, not that section.
All right, let's talk about this review. And I'm gonna do these bullet by bullet. Does that sound like a plan to you?
Sounds like a plan.
Yes? I could just say, hey, that's it. Y'all have a good day. What do y'all want? Y'all want to actually go through some things?
Yes, that would be nice.
All right. So you need, on the first problem, you need to be able to find the difference quotient of a polynomial. So if I give you a polynomial function, for instance, negative x cubed plus 2x squared minus 3x plus 1. I'm going to give you a pretty ugly one, all right? Figure if you can do this one, you'll be fine on the test. And we need to find the difference quotient. So that means you need to remember what the difference quotient is. It is f of x plus h minus f of x over h. That's the difference quotient. Do you remember that formula?
Yes.
Yes?
Once upon a time.
Yeah, a long time ago. So there's like three parts to this. The bottom is h, right? Top left, top right, bottom. Top left you get by plugging x plus h into your function. And then top right you get by plugging x in, but that's actually already exactly x plugged in. And then divide by h. And the goal is to get an h to cancel, right? That's the goal. Yep. So I plug in x plus h everywhere I see an x first. This right here, right? That's f of x plus h, or yeah, plus h. Then I'm going to subtract from that what? The original function, but I should probably put a set of parentheses here because I'm going to subtract the entire thing. Now, if you don't put parentheses, that's okay, but you need to make sure that you change all the signs of this one, right? Take the whole thing, divide by h.
I remember this.
Now we have to actually go through and expand x plus h times x plus h times x plus h. And you do that on the side maybe, do some scratch work. And here's what you'd get. The negative is going to stay out here. I'll distribute the negative in a second. This piece right here turns into x cubed plus 3x squared h plus 3xh squared plus h cubed. You could have also used Pascal's triangle to get that. I'm going to run into my denominator here. Sorry. Minus. Do you want to distribute that now?
Yeah, might as well.
Distribute it? Okay. So when I distribute the minus through, it changes all the signs. So we get plus x cubed minus 2x squared plus 3x minus 1. The whole thing divided by h. Do I have any questions? Crickets.
Yeah,
I'm going to distribute the negative through that parenthesis, right? Just don't forget it. I mean, you have to distribute. If you just leave it like this is going to be wrong, all right? And you'll know because things aren't going to cancel the way you want them to.
We're just going to go off the highest power?
Sorry?
We're just going off the highest power?
How do you mean? Off the highest.
Did you already factor in the 2x plus h squared and all that?
Yes.
Okay.
Like I did this all mentally.
The other two. The 2x plus h squared.
Oh, I didn't put that in there. Oh my goodness. That's what you're talking about.
Yeah.
Yeah, there's a lot more shit up here I didn't do.
Yeah, I was like,
Yeah.
did
I was about to look at y'all, be like, come on, it's the last day, get it together. And then I'm like, oh, wait, it's me. Okay, this was this, right?
Yeah, I was
Okay,
like,
this is this, this is this, this is this, then plus x cubed minus, this is my last class of the semester, okay, just so you know. Little disclaimer, my brain is...
Have you already
I checked out 3.5 weeks ago. No, I'm kidding. All right, that's okay?
When you grade our tests, you know,
Just check it
just
out.
add 50, you know, to whatever you've given us.
And if the number is less than or equal to 100, just give us another 15.
No, I like a calculus class that you drink a lot.
All right, so now what I'm going to do is distribute the negative through. Negative x cubed minus 3x squared h minus 3xh squared minus h squared. So that's what I get when I pass the negative through. I'm going to cubed. Oh my gosh. Okay, hold on. Maybe I need to like hit my head up against the board. Okay. I need to expand this. I didn't expand that yet. What does that become? X squared plus 2xh plus h squared. That's what just this is, right? But then you have what in front of it? 2.
Can we go ahead and just pass?
I'm going to pass it through. So this becomes plus 2x squared plus 4xh plus 2h squared. Then what? This, we're right here, right? So minus 3x
Minus 3x minus 3h.
minus 3h, and then we still have
Plus one.
plus 1.
Minus 1.
That's all of that. All right, so now I'm up to here. So now just these pieces. So plus x cubed minus 2x cubed plus 3x minus 1. All of this over h.
We'll take those. Remember when this was the hard part?
Yes, I know.
Yeah.
Don't you remember when this was the hard part?
Yeah, now it's just like kind of, okay, this is just that. Isn't it 2x squared now?
Is it? Oh my gosh. Okay, maybe I need to just like step out and come
You
back.
need a Red Bull.
I don't know what it
I
is.
have a Starbucks.
I mean, I'm paying attention.
No, I'm serious.
What are your plans for
He's like, I've got
summer?
Hmm?
What are your plans for the summer? Are you already like?
I've got a lot of
We
plans.
need
Maybe
to
I need to get into this right
Try
here.
to keep him as focused as we can.
My little Crown Royal bag.
There you go.
There we go.
Here.
There we go. That's so inappropriate.
He's like, what? He's like, disclaimer alert, there was no alcohol used in this.
Right,
No.
right.
So inappropriate and conveniently it's behind the camera.
Yeah, conveniently behind the
Yeah, this will be my last semester here. All right, we should get a lot of cancellation here, right? Let's see, this negative 3, that's the first one I see. The ones, what else? X cubed, negative x cubed, 2x squared, negative 2x squared. One big hint is that the stuff with h's should still be there. Anything that doesn't have an h should probably go away.
Great.
Are we,
Okay, fine,
are
well, I'll just-
we good?
Yeah.
None of us have H's,
Nothing.
we'll go away.
All right, so here's where I am. I have, can I go ahead and go to the next step, which would be, since they all have h's, to factor an h out of the top?
Sure.
Can I factor an h out? If I pull an h out of the top, I'm left with negative 3x squared, that's an h out of this, minus 3xh, because I pull a single h out of this, minus h squared, because I pull a single h out of this, plus 4x, because I pull an h out of this, plus 2h, because I pull an h out of this, minus 3 for that one, and that's it, right? All over h.
All divided by.
And the h's cancel, so the final result is negative 3x squared minus 3xh minus h squared plus 4x plus 2h minus 3. That's it. That's your difference quotient. And when you get to Cal 1, what you'll do is you'll let h go to 0 now. But that's what we want here. Do you remember doing this?
Yeah.
Okay. So go back and review some of those problems. I'm telling you I'm going to stick to polynomial functions. There were some that I did where I gave you rational functions and it was a little more complicated. So when you go back and look, just you can focus on polynomials. Understand? All right, next thing, you need to know how to complete the square. Specifically, I'd like to make sure you can complete the square on a on a quadratic function for something like this. See if you can remember this. Find the vertex by completing square.
Can I get my note about that?
In class, I gave you a formula for the vertex. It was a vertex formula. H and K, yes, H and K. That was the shortcut, wasn't it? H was negative b over 2a, and K was f of h. It's plugging that answer into. So let's just do it this way to see what our answer needs to be, and then we'll actually do it by completing the square. So h for us should be negative b. What's negative b? You get 8 over 2 times 2, so 8 over 4 is 2. And then you plug that in. K is f of 2. So plug 2 into this, and you have 2 times 2 squared minus 8 times 2 minus 3. So this is 2 squared is 4 times 2 is 8. You have 8 here, minus 16, minus 3, negative 11.
Yeah. Sounds about right.
So our vertex should be 2, negative 11, right? That's what we should get. But I'm going to do this by completing the square instead. And this is what I want to make sure you can do, because this will come up again. You'll need to be able to complete the square. So when we do it, we look at the quadratic. And the first thing we do is we make sure that the coefficient on x squared is a 1. Does this ring a bell or not?
Yes.
A little bit? Make sure it's a 1. It's not, right?
So then we just divide it all.
Can't divide because it's not an equation.
Right.
So I'm going to factor a 2 out. Okay, so I'm going to take a 2 out. Okay, but what about taking a 2 out of this? It's not a common factor. I make it into a fraction. What fraction? Minus 3 halves, 3 over 2. Do you remember doing that? Something like that?
And I said it the other way.
But you're good?
Yes.
Okay.
I understood.
Okay. Once we get to this, what we do, you take half of the number in front of the x, right? I take that number, negative 4, and I take half of it. Always half of it, right? And that gives me negative 2, right? And then what do you do with that number? You square it. Always square it, and you get 4. That's right. Now you're going to do plus 4 minus 4, right? You're going to use this number, and you're going to add it and subtract it at the same time. So I'm going to move this up here. So this becomes 2x squared. Where do I add and subtract the 4? Where do I do it?
Right after that.
Right after this, right? Right after this. I come in here and I add and subtract 4. That's really a 0, so it doesn't change the problem. Why do I do that? What am I able to do at this point? Split it up, right? The first 3 terms inside the parentheses are guaranteed to factor. And they will be, this will turn into something squared, right? What is it? X minus 2. And the minus 2 comes from this number. right? What do we still have right here, though? Minus 4 minus 3/2, right? That's still in parentheses, and there's still a 2 out front, isn't there? Couple of more steps. Put these two together. So get a common denominator because you're adding two fractions. Negative 4 over 1 minus 3 over 2. This is negative 8 over 2 minus 3 over 2. Negative 11 over 2. Yeah? So now I can write this. 2x minus 2 squared minus 11 over 2. And my final step is to distribute the 2 back through. And you have to be careful because when you distribute, the 2 goes, and it can't go in here because you have to square that first. So the 2 is just going to drop out in front of it. And then the 2 here is going to kill off that other 2, isn't it? On the bottom. So you're going to have 2x minus 2 squared minus 11. And that looks like, that's our function, right? F of x. That looks like this format of a quadratic function, which we call the standard form. And when you write a quadratic in standard form, you can see what h and k are, right? H is the opposite of what you see here, right? So h is actually 2, and k is negative 11. So you get the same thing. Be able to complete the square.
We have to be able to do it that way?
Yes. Yes, because that's a skill you need moving forward. Now, if you're ever asked to find the vertex of a quadratic function in the future, I would use this shortcut. But completing the square is just a process that needs to be understood, and you can pull it out of the bag anytime you need it.
I understand that's going to be more universal and that we'll be able to use it for much longer.
Yeah, you'll be able to use that to find like the center of a sphere,
Basically,
the focus of
finding
an.
the square is the more powerful function.
Yes, and it extends beyond just quadratic functions. It extends to other concepts. The next one, quadratic function word problem. So I thought that I would give you a word problem. We never really, I think, focused too much on this. I think that we talked about a problem of like falling objects on Earth, but I never got to it. Do I remember that? Do you remember me mentioning it?
I remember you mentioning that it would be a thing.
Yeah, that we would get to it.
Yeah.
We never got to it, right? So I thought what I would do is I would put something up on the board and see how you handle it. All right? Let's just see what happens. Okay.
I'm all going to have heart attacks.
The position of an object, in this case, I'm going to say it's a ball fired into air, is given by d of t equals negative 16 t squared plus 30t plus 5. Where t is time in seconds, and d of t is the height of ball in feet. Here's the questions I'm going to ask. First of all, what is maximum height of the ball? 2. When does it reach maximum height? Three, when does it hit ground? And 4, nah, that's good enough. I mean, that's 5, yes, you're right. That's good enough. All right, so let's try and understand what's going on here. We have a ball that's being thrown up into the air, and it comes back down, right? We're being told that the position of this ball is modeled by this function, which happens to be a quadratic function, right? And for this particular quadratic function, we know that it opens which way? Downward, right? If t is time, right, and t is like the x, then I can call this my t-axis, and this would be d of t, which is the height of the ball. How high is the ball off the ground in the beginning of this problem?
5 feet.
5 feet. How are you getting that?
Because it's plus 5.
Yeah, if you let time be 0, that's the beginning, right? This is dead, you just get 5. So my ball is 5 feet off the ground. Now, the ball is fired up into the air, so it's going to go up, right? Time's going to start, it's going to start going up, and then it's going to come back down. And when it does it, it's going to have some parabolic shape like that, right? What is part 1 asking us for? Part of it, yes, not the whole thing though. What is the height of the ball?
Yeah, what is d of t?
What is the max height of the ball?
What is the max height of the ball?
So what's the vertex?
Not the whole vertex.
So just half.
What is the d of
Just,
t axis?
just the what?
It's h, right?
Half of the vertex?
You tell me. Think about it.
Oh, no, okay.
Isn't HK really correspond to the like x and the y? In this case, this is the t and the d, right? This is the time and this is the height.
We need to find the d.
So part 1 is asking what the maximum height is, right? Which would be this value, which is the k, isn't it? It's the y value. So do you understand this wants the k of the vertex? What does part 2 want? When does it reach it, right? When, time, when. When do you, yeah, that's the h of the vertex, understand? And then what is the last one? When does the ball hit the ground?
That's your x-intercept.
That's your x-intercept. Now, we can call it x-intercept because we all understand what we mean by x-intercept. Technically, it's the t-intercept because it's the t-axis. But I'll put x-intercept, right? Because that's what makes most sense to us right now.
K, the h-intercept.
So how do you find k and h? Well, we know that already, right? We just find the vertex. And so I'm going to go get the vertex for this.
Complete square.
I'm not going to complete the square. I'm going to use the shortcut. So what is h? We have to get h before k, right? We have to get h before k. So h will be negative b over 2 times negative 16. You'll need your calculator. Negative 30 over negative 32, which is approximately positive point.
It's 0.9375.
9375.
Yeah.
Okay, we'll just round this to 0.94. Is that okay with you? Close enough?
I guess.
That's good.
Okay,
Better than what the book does.
that's h right there. Now, to get k, we have to take 0.94 and plug it into the function. So again, this is going to be more calculator. Do you understand that the word problem is just asking us to apply what we know about parabolas? Right? You just have to be able to interpret the problem. That's all. So k is plugging h into this. That's d of 0.94, which is negative 16 times 0.94 squared plus 30 times 0.94. You'll have to get your calculator to do this. Plus 5. Where's my calculator?
19.0624.
Any seconds on that? Ah, good. Any seconds?
See what you did there, the time, it's talking about time.
0.94 squared times 16.
What'd you get? I got 19.06.
Okay. You got 19.0. I may as well finish this off. 30 times 0.94. That's 28.2 plus 5. Whoa. Hold on. 28.2. Bless you. Honestly, am I the first person to ever say anything about your sneezes? Really? Wow. 19.06, somewhere around there. Close enough? Close enough. 19.06. 19.1 if you want. I'm not going to be real particular about this. 19.06 is K. All right? K.
Okay.
Yes, that's K. All right, so let's try and answer this. What is the maximum height of the ball? 19.06 feet, because I told you that D was measured in feet, right? And when does it reach the maximum height?
0.94 seconds.
0.94 seconds.
And on the x-intercept, you would set the whole equation equal,
Yeah, so when it hits the ground, you have to actually set this thing equal to 0.
which is fine.
Which is, no, not set t equal to 0, set the equation equal to 0. Which most likely, for part 3, what we're going to need.
Do you want us to show us our work for that, or?
Yes, you need to go through and work it out. You set this equal to 0. So what you'll probably wind up using there is a quadratic formula.
That'd be the easiest.
Yeah, because then you're not going to be able to factor that. So you remember the formula?
Negative b
Negative b
plus or minus
square root
of b squared
900
Minus
minus
4a.
4a 16c
all over 2 times negative 16. Whatever that is.
If you get a plus or minus, you would just do the plus.
You're going to look at both answers and you're going to do the one that makes sense. Because remember in our picture, it started 5 feet off the ground and went up like this. And it hit here. We know that there is another x-intercept back here, but it doesn't make sense because it's negative time. So that negative answer we'll throw out.
Wait, we're not.
Questions? Do you want to know what this answer is?
Back in time.
20.
Have this far, man, we'll find out.
Oh, man. Okay. I shouldn't have done it that way. All right. You should get 2 answers. I'm going to only give you the positive answer. 2.0, that's not a 0. 2.029. Seconds.
That's not a long time.
Not a long time. It does turn out that in the real world, if you throw something into the air, that it's going to travel in a parabolic path, and so that there is a parabola that models all objects flying through the air. So it's actually applicable to the real world situation. Now, once you put air resistance into the problem, it does create some issues, but it's good enough for most applications. Like if someone jumps out of an airplane, you can figure out how long it's going to take them to come down.
We also need to know why they're jumping out of a good airplane.
For fun?
That's like, we need to save this person. All right, first let me find out how long until they hit the ground.
Yeah, how long do we have? Up, too late.
Let me get my quadratic formula.
Okay, I need you to be able to sketch a piecewise function.
Piecewise function sketch? I don't remember this one. I do?
Yeah, it's like between these 2 points, this is the equation. Between these 2 points, this is the equation, and this is the graph, this is the equation.
There we go. So this is the one where you have to pull out the toolbox function, and you have to look at the functions that you should know what they look like.
Yeah.
And so what we'll do is we'll start with, let's see, do we know what this looks like?
Taking down.
Root x? What is root x, the parent function, the base function, look like? What is root x? Root x looks like this, right? That's root x. And I'm going to take that and move it left 2, opposite of plus, and then flip it over. So it's going to go like this. 1, 2, moved over, and then negative is flipped over the x-axis. So I know it looks like this, right? That's just a basic sketch of what's happening. That's the whole function, right? What does the absolute value of x minus 1 look like? Yeah, the base function is this v, and then I'm just going to take it in down 1. So if I draw that, it's going to look like this. Right? Now what I need to do is go and cut this domain at x is 1. So at x is 1, you're actually looking here, aren't you? Like this. And you only want to draw the graph of this thing when you are smaller than or equal to 1. So that means you want to cut this part off, right? And you only want to draw this one when you're bigger than 1, which means you want to cut all this off.
Oh.
And
I remember.
that's your piecewise function. Does that ring a bell?
Yes.
It's been a while.
See, if you would have said sketch, I would have.
Oh, sketch it. Yeah, it does say sketch on here.
It does say sketch.
Piecewise function sketch. Make sense?
Yeah, it did sound kind of sketchy.
Okay, analyze the graph of a function to determine various things. That's where I give you a picture and I ask you like, hey, what are the x-intercepts? Hey, what's the domain? Hey, where's it increasing? Where's it decreasing? Where is it positive? Where is it negative? Do I need to go through these? You're okay with those? Y'all always seem to be okay with those.
When is it greater than 0? When is it less than 0?
Yep. Okay, you'd be able to completely factor a polynomial. So I thought I would do one of these. Let me see if I have my good old faithful in here.
Some of these stuff I forgot.
For some reason, as a kid, whenever I think about math teacher, teachers, I'd always think that they would look at everything like an equation.
F of x equals x to the 5th minus x to the 4th minus 16x cubed minus 16x squared minus 17x minus 15. Completely factor this polynomial. You can do that when you have 4 terms.
Wait.
Synthetic division, good.
Right.
Yes.
So 1 is the 15.
That's right, good, good. What are all the factors? So you have to look at the number in front, 1, number in the back, 15. What are all the factors? When it was a 1, it was nice, wasn't it? When it was a 1 out there, it was the nice case. I'll make sure it's nice on the test for you that way, okay?
That would be nice.
Thank you. I appreciate the encouragement there. So I'm going to look at 15. I'm going to look at all the factors. What are all the factors? I'm making a list.
1, 3, 5, 15.
1, 3, 5, and 15. Those are the only things I'm going to try for synthetic division. I'm going to hope I get it.
I hope you get on the -1.
Am I going to start with 1 or -1? What?
Doesn't matter.
I'll start with 1, and in here I'm putting 1, -1, -16, -16, -17, -15. Well, that's a lot of negatives there. Oh,
Well
no.
depressed now.
You like this.
There's problems too negative.
Drop the 1.
Satisfaction of that answer.
1 times 1 goes here. Drop, you get 0. 1 times 0 is 0. Drop the -16. -16. -32.
This is stuff they're negative, they're just gonna get worse.
It's going to get worse, right? -32. This is not going to work, right? Okay, so that failed. Now move to what? -1, right? That's what I asked you to do. So what happens if I do -1 here?
Things a little more positive.
Yeah.
You're so
You're like my grandfather. Got puns for everything. All right. 1 drops, -1, -1 here, and -2, right? Multiply here, I get 2. -14. Put that here, we get 14. Drop down, -2. Multiply, 2. Drop down, -15. 15, and we get a remainder of 0. Good. Ooh.
This is very good thinking.
And don't forget what this tells us.
That x is a positive 1.
X plus 1, and then this is the remaining polynomial.
And then we've already tried 1 and -1, so we're just going from there.
No, you go back on the -1 again.
You do -1 again. You do -1 twice.
So we go back to try 1.
It's not going to work. Okay. You don't have, no, you don't have to try 1. We already tried 1. You have to retry -1, the one that just worked. But it's not going to work. Can I move on to the next one? So the next one we would try would be 2, right? 2 is not going to work. So you try -2. -2 is not going to work. So you try 3. It's not going to work. So you try -3. All right? -3 will be the next one. So I'm going to do -3 on these numbers, right? These? -3 on 1, -2, -14, -2, -15. 1 drops, -3, -5, 15, 1, -3, -5, +15. So that works.
You did it on your first try.
So this tells us we have x plus 3, x what?
Plus 1.
X what? X cubed, because it's 1 power less than what we were working on. Minus 5x squared plus x minus 5. Are y'all okay with that?
And now we can see about factoring.
Yeah, I think, Stephen, now we can do grouping on this piece because you have 4 terms. So I'm going to come back over here and just write where I am right now. I've got this. So if I split this down the middle like this, what can I pull out of the first 2 here? X squared And then I'll have x minus 5 left. And what do I pull out of the other one? Be careful. Hold on a second. This was minus. Apologize. That was minus. I pull out a what there? Positive 1. X minus 5. And that turns into x squared plus 1 times x minus 5. Or you can say it the other way around. X minus 5 times x squared plus 1. Yeah, then all the other ones together. So we should get as our final result the x plus 1, the x plus 3, and then you just told me x squared plus 1 times x minus 5. What about that x squared plus 1?
It's not going to factor.
It doesn't factor. It's the sum of squares, and we don't have a formula.
It's
So
going to be imaginary numbers.
that's right.
Solution.
That's it. We're done. So we just leave it just like this.
No, you still need to find out your x-intercepts.
No, no. Nope, factor. That's all I said.
Oh,
Just factor. I'm going to give you a polynomial, and I want you to factor it. I'm not asking you to sketch it and do all the multiplicity, bounce, cross, all that. We're not doing all that. It's just show me you can factor. Show me you know how to factor using synthetic division. That's what I want to see. All right, sketch a polynomial. Oh, well, the next problem is sketching, but this is different because I'm not asking you to sketch it. I'm not giving you the function. I'm giving you criterion. Now, we did this where I said, like, sketch a polynomial function that has these characteristics. The degree is 5. X equals -1, 2, and 3 are zeros. And f of 0 is 10. Something like that. Sketch me a polynomial function that looks like that.
well, it's going to go like that.
Which, like this?
Yeah.
Or could do this also. It's a degree 5, right?
Yeah, it doesn't say,
It doesn't say, does it?
but it could go either way.
Could go either way. So what we do is we start with the idea that we know the zeros. If we know the zeros, we know factors, don't we? So here's what I can tell you so far. F of x is equal to, I'm going to leave a space here on purpose, x plus 1, x minus 2, and x minus 3. I know that much so far, right? Because if I plug -1 in, I'll get a 0. If I plug in 2, I get a 0. If I plug in 3, I get a 0. But is this a degree 5 polynomial?
No.
No. So I need to make one of these squared or cubed, right? What do you want? Cube? You want a cube one? We can do several things. We could do squared squared.
Well, you just have to make
Right.
sure that it's going which way you want.
You have options. Everyone's answer is going to be different here. It depends on what you want to do.
Because if it's even, it touches. So you can do it.
But this is not even. Oh, yes, yes. So our graphs will look different. Yes, they will. So what do y'all want? Do y'all want to do, if we do cubed here, then this will be first power, that's 5th degree. I could do cubed here, that's 5th degree. I could do cubed here, it's 5th degree. I could do 2 here, 2 here. I could do 2 there, 2 there. I mean, right? I mean, what do y'all want to do?
Why don't you just put it on the graph and then
I don't
figure
care.
out where it should go?
What do you mean?
Like you can put your x and kind of figure out where you want it to go.
Yeah, but that's what we have control over. If we look at these, we have -1, right? We have 2, and we have 3, right? That's what we know. So, I mean, that's like the basic information. Everyone's graph has to touch those points, no matter what. But the bouncing and crossing is your protocol. You do that. So what would you like?
Just a 3 on the x plus 1.
You just want to put a 3 on this one? Okay. So that means it's going to cross through all of them, isn't it? Because multiplicity is odd for all of these, so I'm going to cross through every single one of them. I still don't know, though, if I do this or this, so that's where this comes in. This comes in right there. That's going to tell me. Let's see. F of 0 being 10 means that when I plug 0 in here, I should get 10, right? Now, I left a space. I don't know if y'all remember this. I left a space out here because there's going to be some constant that I don't know. That constant's going to dictate the left and right behavior. So,
But if I remember right, you said it wasn't that like imperative.
well, you have to figure out what this number is because that's going to tell you whether or not you're this or this.
Right.
Let's plug 0 in. What happens here? We get 1 cubed, right? Times -2 times -3, which is 6. Hey. I told you last time the same thing. I know it's the last day, but I don't mind taking 10 points off your final on the last day. So let's not do that. Well, don't lay down in my class like that. Okay? All right. It's one thing to nod off. It's another thing to like lay yourself out and go to sleep. All right. So this needs to be equal to what? 10, right? Right. That's what this says.
Yeah.
So over here we get what? 6a must be 10, which means a must be 10 over 6, which is, you want a decimal or just leave it as like 5/3? It's a positive number, right? That means if I go to my graph and I go to 0, right, I should be up here, right? Everything else is now determined. Why is everything else determined?
Because you have to cross.
I have to cross, right? So if I cross from here, I have to go down like this, right? I come back this way, I have to go through here, I have to cross, and then I have to come back here and I have to cross. So that would be an acceptable sketch. But if someone changed this, right, and they put the cubed here, it's going to change the picture. If they put squared and squared, it's going to change the picture.
Could still be correct.
I'm sorry?
Could still be correct.
As in?
Like it would still match that criteria.
Yes, that's right. So everyone, I think when you were asleep, I was saying, you know, everyone's going to have a different answer.
Absolutely.
I'm giving you a hard time.
You are.
But at the same time, I find it very disrespectful when people sleep in my classes. All right. Sketch polynomial, sketch a rational function. Let's scratch that, man. Let's scratch that. Yeah, I don't want to do that.
Alright, well, we studied that, but if they end up on my final, I'll be very upset.
Why?
I will be cross.
I'm saying scratch it. I'm not going to go over one.
Oh.
Let's not emphasize that. Find the domain of a function algebraically. So that means someone gives you a function. You know, I'll give you a couple of them to look at. X minus 2 over x squared minus x minus 6. Another function you could look at, square root. Oh, this is one of my favorites. Square root of x squared minus x minus 6. And then another one, h of x is 1 over the square root of x squared minus x minus 6. Let's take a look at all three of these. They all have little differences in them. Domain. So what is it that you can tell me about f?
It's got an x-intercept at 2.
X-intercept at 2, yes. But domain-wise, what are the things you can or cannot plug into that function?
Well, it's gonna have vertical asymptotes.
Yeah, you have to make sure that that denominator is not 0, right? So you're going to go figure out when is that 0.
So 3 and -2.
Yep, so you just factor this out, right? Take that, set it equal to 0, ask yourself that question. When is it 0? You get x minus 3, x plus 2 equals 0, right? And so your two places that you have a problem are 3 and at -2. These are not in your domain. No, because I'm asking for domain. Those are not in your domain, right? You don't want those included. So on a number line, you do not want -2. You do not want 3. How do we say that in interval notation? Negative infinity to -2.
Union, go -2 to 3.
Negative infinity to -2, parenthesis union, negative 2 to 3, union 3 to infinity. Remember this? So to do a problem like this, you have to be able to solve a quadratic equation, right? This problem's different because it's okay to be 0, right? You can take the square root of 0.
Yeah.
We just need to make sure it's not negative. So what we say is we want to know when this is bigger than or equal to 0. I'm going to share something with you. I'm going to mute my camera.
Wait, so only 2 out of 40 people got hired?
No, we only hired one because even of those, only one of them was,
Qualified?
well, no, just,
You only needed one?
no, we had 2 positions, but sometimes you just don't have the right people in that pool, you know? Just you're willing to wait to see what else might come down the line later. Okay, so look, I mean, this is fundamental. I mean, you're not going to sit there and teach this to someone if you can't do it, right? So, all right, so here what we do. Let's see if you remember, or if you're going to do what they did.
Well, I would set it equal to 0.
Good. So you've already exceeded what 4 people couldn't do. Yep.
So-
They worked it as an inequality the whole time.
Can I see
You're
the
hired.
application?
You're hired. Okay, so this is, what do we call this? A quadratic inequality. And the first step is to change it to an equality and solve. And we already know the solutions to this, right?
Yeah.
And if I put this on a number line, negative 2 and 3, I do want those or I don't want those?
You don't want those.
I don't?
Because they are, no wait, you can have those.
I do want those, right?
Yeah,
Equal to.
So equal to 0 is okay.
As long
But you make
as
the
it's greater than
parabola.
0.
Good.
It's a square. and then
At this point, it's just a matter of,
Yeah, and then
do we
where's the
include this
quadratic?
stuff? So we want to know when this thing is
Above or below 0.
bigger than 0. And that is a parabola that opens up. So I know that this thing, if I were to draw it in here, does that. And so I know that I need this stuff over here and this stuff over here, right?
But if it's equal to, would you put it in brackets?
If what's equal?
Because like the inequality, it's greater than or equal to, right? So when
This
you
means
write-
greater than or equal to.
So when you write your coefficient.
Oh, yes, I'm not done. I'm going to write it down now.
Hold on, why
Yeah.
is it going down because it's positive? Oh wait, you're right.
Positive,
I'm
so
sorry.
above the x-axis.
That's all right.
That's all right.
An old fart, sorry.
You almost got hired.
Yep, that was it.
That's like, I already got fired and I haven't even hired yet. So much for that job opportunity.
There we go. That's the answer, right? So